So I'll continue with the introduction. So as I said before, first of all, it's very nice to see this big audience and the great interest in the webinar. And my name is Christian Knorr, and together with Dagmar Lauer, we will give you now some insight into our technology from ArianeGroup, called the RIT2X engine. And we will also give you some insight about the RIT technology in general. And before we are doing this, I will also spend few slides only to give some background about the GIESEPP MP project. So what is the setup? What are our objectives in the project? So that will be a part of the next presentation. And well, you may know ArianeGroup maybe more of the big products that are behind the name of the company. However, we are located in Lampolzhausen, Dagmar and myself, and from Lampolzhausen we actually serve the orbital business, let's say, and so orbital propulsion is an important topic for us, and now with EP also as a, let's call it, a new element of the range of products that we provide to the market. So let's have a quick look at the GIESEPP MP project. As Linda introduced in the beginning, this is one of the two projects that are contributing to today's webinar. And first of all, GIESEPP MP, so what does the name stand for? GIESEPP is the development of a gridded ion engine standardized propulsion platform. That is the GIESEPP. And MP, we will come to that in a second. It's the medium power range that we are focusing on for the current project. So the main objective is not only to develop a single component, let's call it, so not only a thruster, and you see the schematic here, which is quite similar to the one that we saw before from Fabien. So you see the spacecraft, we have the PPU, we have the RFG, we have the thruster, neutralizer, and so on, and all the different wiring in between. But we want to develop here a propulsion platform. That's the purpose of the GIESEPP MP project. And this platform shall focus on a geostationary orbit. And on the bullet point 2, you see the topics which are in focus here of GIESEPP MP, which is the thruster, the element that we will come to in a second more in detail. It is about the propeller management side. It is about the PPU and all of this. This is also important to note. This is, let's say, also one of the objectives of the EU in funding such projects. All of this not only as a single sourced element, but we want to provide a platform where in the end, the customers also have the flexibility to choose components that are most appropriate for their platform. And well, of course, at the moment we have in this setup, we have dedicated components, and we'll come to that in a second, who are the contributors, especially to GIESEPP MP. But the general idea is not to have that as a closed system, but it should be a platform that can serve different, let's say, flavors, maybe from a technical point of view, as well as also from a contractual point of view. When we're talking about EP, there is a, let's say, wide range of products available already on the market. And Fabien had already, let's say the two sides of EP that are of interest for the prime companies. This is high thrust or high ISP. And with the technology that we provide as ArianeGroup, we want to focus on the high ISP side. And that's why we chose for the gridded ion engine technology. And Dagmar will later on go a little bit more into detail and explain the specific benefits of that technology. And so as part of the GIESEPP MP, we want to come into a position to have a technology leadership in the EP world with the platform that we provide. Also referring back to the presentation of Fabien, of course, competitiveness is an important topic. So it's not only the technical side. With a propulsion system, of course, we also need to make sure that this is also on the financial, on the budget side, a competitive solution. And so what we are aiming for on the individual elements, no, so not only the thruster, on cost efficiency, and this also involves a kind of standardized and high quantity industrialization process or manufacturing process, and in the end also a significant cost reduction in the manufacturing of the different elements. And this is, let's say, a discussion that is currently, yeah, very much ongoing. And I'm sure you know that when you're working already in the field of EP, our thruster is at the moment specifically provided for xenon. However, there is, due to the cost impact that Fabien mentioned, there is also the possibility to have an alternative propellant to be used with that thruster. So we can also operate that with krypton, but I think this is a dedicated discussion that could be maybe part of a separate or another presentation. It's just to mention that here. And in the end, as part of a EU project, of course, the EU is also interested in having a technical independence of Europe. And this is also true here for the field of EP, so that we can provide all the elements being somehow independent from other sources. And this is indeed a challenge. So especially when we look into electronics, for example, when we look into specific components, then it is not as simple to say, well, we just build everything here, because we have different players on the market. We have a long process of qualifying the different products. So this is a dedicated goal or objective of the GIESEPP MP that we also have in focus here for our activities. Now, looking a little bit into what is the ambition. So what do we want to end with the activity? So Dagmar, if we can switch to the next slide.
I'm trying, but my computer is not willing to.
Okay.
As always.
So we are having actually 3 pillars on which this is based. And these 3 pillars are the technology, the market, and the environment. So that is what we need to keep in mind. And all those 3 together, they serve the objectives that I just had on the slide before. And I will now not read out all the individual bullet points here, but of course, we need to take into account the technology challenges. And I would mention here, we already talked about it shall be a standardized European solution that we want to provide, but I will specifically mention here, we want to provide a thruster not only with a single operating point, but we want to have a multi-mode thruster, meaning that we can adapt the operating points to whatever the mission needs within the range of the product. And we will have later on a slide showing the capabilities of our thruster. But we also need to take into account the market needs, which is the economic side, of course, the industrialization, and also within the industrialization, also the paradigm change that we see on the market, going into constellation programs where we have now in the meantime, let's say a total different number of components that need to be produced for that market. But this also opens up, let's say, the floor for having really industrialized processes, and by that bringing down the cost significantly for our products. And in the end, last but not least, it also shall be environmentally friendly, which is, let's say, for electric propulsion, of course, a strong argument, because we're having a propellant which has no negative impact on the environment, and of course then also the efficiency of the system is a big stake in that. So now, after having understood the objectives of why are we doing GIESEPP MP and what are we focusing on, I'd like to quickly give an overview of the participants of GIESEPP MP. So you can see here on the map, and it was similar to what you saw in the beginning from Linda, but now specifically for GIESEPP MP. These are the partners for the GIESEPP MP project, and going from left to right, counterclockwise. So we have Airbus, and it was very cool to have the presentation from Fabien here in the beginning, because this is actually the satellite system side, the prime side, with respect to market needs. So that is a very important view. And then also with the system side on the propulsion system. Then we're having CRISA, and we will have other presentations later on. And CRISA here in the consortium being in charge of the power processing unit, especially the PHV part, but we will hear that in a dedicated presentation later on. Then we also, for the electric propulsion, we also need dedicated test sites. And although, let's say, each company have their facilities, but we're having here Aerospazio in the consortium with specific facilities for EP testing, which is a strong stake, and therefore they are, of course, a very good partner for that. And then ArianeGroup, I already spent some words on ourselves. So just to repeat here, as ArianeGroup, we don't we have not only our big products like the Ariane rocket, but here, especially from Lampertshausen, we are serving the orbital market with a lot of products around propulsion systems, orbital propulsion, from chemical propulsion, electric propulsion, lines, feeding systems, tanking, and so on. So all that is the portfolio that we can provide from ArianeGroup. And then further, we also have very, very good support on the scientific side from the University of Gießen, and later on we'll also have a presentation from Konstantin Keil, which is on the one side scientific support, but also support on component level testing, which is very valuable to also have here the academic view and academic experience brought into the project. And last but not least, as introduced in the beginning by Linda, we have also here a specialist in communication, and this is especially important here when we are talking about a EU project. And let's say one of the results is what we are currently having, this webinar, and I think it's a great thing, Linda, that we have you on board for these elements and for having these opportunities also to provide these information to the public. So now that you know the consortium, let's go back again to the technical side, and especially to the thruster side. When we talk about our ArianeGroup solution, so the RIT2X engine, actually, what are we looking for? Actually, with our RIT technology, we want to serve a wide range of different applications. So actually, we are talking about different platforms, and we're having 3 different ranges that we want to serve. So we want to serve small satellites or low Earth orbit in the 500 watts class. This is, to be honest, not the RIT2X product. We'll have an overview of the different products later on in the presentation, but it's the same technology, same principle that we will work on. And then we switch to the 5 kilowatts class, and this is now what we call the current product, the RIT2X. And this is the medium power for geostationary orbit or for navigation applications. This is a totally different class of with respect to the engine capabilities. And finally, also we want to serve missions where we have an even higher need for propulsion system. So we also want to go into a 20 kilowatts class. Our solution here is that we build a cluster of thrusters for such missions. So actually, it's simple math that we have 2 or 3 of the RIT2X engines to serve these elements or these applications. So that is our portfolio that we bring to the market. But here in GIESEPP MP, we focus on the number 2 that you can see here on the slide. It's the 5 kilowatts class. That is the RIT2X engine, and that is also what Fabien mentioned before in his presentation of the missions. So now with this introduction of what is GIESEPP MP, what is our background here as ArianeGroup with the electric propulsion products, we will now jump a little bit more into the RIT technology. So what's behind and what's, let's say, also the difference maybe to other technologies, and why do we believe that our gridded iron technology is the one with which we want to serve the market. And with that, I give the floor to Dagmar to go more into technical details of our thrusters and our technology.
Thank you, Christian, for the first part of the presentation. I'm going to go a little bit deeper into the technology we have at ArianeGroup available. So first of all, we are already talking about the RIT technology, which is short for radio frequency ion thruster. So the principle, the basic working principle of the thruster is the propellant is ionized by a radio frequency field. The ionized propellant is then accelerated due to a grid system which has an electrostatic field, and doing so the thrust is generated. As the thruster is expelling positively charged ions, we additionally need a neutralizer to get the charge balance for the satellite. I will talk a little bit more about the thruster later on, a little bit deeper into detail, but this is the basic principle we are talking about. Some of the thruster advantages already came up. It's highly scalable, so we have thrusters from the micronewton range of thrust up to more than 200 millinewton thrust. It's very efficient, as Fabien already mentioned. Furthermore, we have a very good high voltage insulation, as we use high voltage for acceleration, but it's insulated due to the discharge vessel out of ceramics. We have a simple and robust design, and the thrust can be controlled in a very, very good way by adjusting the electrical parameters of the thruster. So in this slide, you can see some pictures of the what we call RIT family. So on the upper left, you can see the RIT2X, which is a thruster for fine thrust applications in the micronewton range. It can be used for fine positioning of satellites, mainly scientific missions. In the middle, you can see the RIT10 thruster, which can have a power up to 700 watts. And on the lower right, you can see the RIT2X thruster, as already mentioned, which can be operated up to a power of nearly 8 kilowatts input power. In this slide, you can see an engineering model of one of the thrusters we have at ArianeGroup. If you take a look at the right picture, you can see on the bottom, you can see the gas is inserted into the discharge vessel, or also called discharge chamber, via the gas inlet. It's ionized by the RF coil, which is surrounding the the discharge vessel, and then it's accelerated through the grid package or extraction package, which contains a lot of extraction channels. You will see this in a later slide. What you can also see in the right part of the picture is the neutralizer, which brings the electrons to get the satellite not charged by the ions expelled from the thruster. As it is an electric thruster, of course, you need some harness to supply all the elements of the thruster with voltages and current. Well, in this slide, I'm going to talk a little bit more about the acceleration of the ions. As I said before, the ions are accelerated by a grid system. Such a grid system contains of two parts. The part which is directly close to the ions is the screen grid. It has a positive high voltage applied, and the second grid is the so-called acceleration grid. And this one has a negative high voltage applied. And doing so, you have an electrical field in between the grids applied. And by this field, the ions are accelerated from thruster to space. And doing so, you generate thrust. And what's important is that the velocity the ions are accelerated is dependent, first of all, on the propellant you use, on the mass of the propellant, and the charge of the propellant. For example, if you have single charged ions or double charged ions, this is what you can imagine. And of course, on the extraction voltage, meaning the voltages you apply on the screens. And those are also the values which are the most important for calculating of the thrust. And this is why you can adjust the thrust very good, in a good way, in a good manner with the thrusters, with these type of thrusters. As you can imagine, you do have some losses in the thrusters, so the actual velocity in the beam is calculated from the ion velocity with the efficiency, the so-called mass efficiency you apply on the thruster. And so the total power of the thruster is the part which is in the beam generating the thrust, plus the part which is used for ionizing of the propellant. On the right side, you can see an example of one thruster of the RID-22 grid system. And just for your imagination, this grid system has more than 7,200 extraction channels in the grid system. So it's really, the number of extraction channels is one part of the thruster defining the thrust you can reach with your device. So it scales also with the size of the thruster. In this slide, you can see the example of the thruster we are currently developing for the GIESEPP MP project. It's not only usable for telecommunication satellites, as has been already stated, but it could also be used for science missions, for example. It has a really big thrust range from 80 to 260 millinewton with an ISP varying from 2,500 to 4,000 seconds, and the power is somewhere in between 2 and about 8 kilowatt. So you typically have two thrust modes available for those telecommunication satellites, as Fabien already mentioned before. The first one is station keeping. This is the part where the satellite is in orbit and you need a lower thrust, but you would like to have high specific impulse. And the second one is to get the satellite into the orbit. This is the part where you would like to have most thrust available as possible, because it is directly linked to the time to get to orbit. And the RID-2X, currently developed within the GIESEPP MP project, is aiming to serve both operational points, the one for station keeping and the one for orbit raising. This is a slide which continues a little bit what Fabien already mentioned. We believe the RIT technology is very interesting for telecommunication satellites as it saves propellant and thus saves a lot of mass you have to take with you. It saves, yeah, even you can see in the numbers, we have calculated for 3 different kind of missions, meaning launch masses of the satellite. And you can see you save 1/3 of the propellant you usually use using chemical propulsion. And it is already also more efficient than when you use Hall effect thrusters, because the specific impulse of the RIT technology is higher than for the Hall effect thrusters. So this gives you 2 options. First of all, you can use more transponders on your satellite, or if you don't have the power available, for example, you can aim to use smaller launchers, and doing so maybe save some costs in launching your satellites. So this is the reason why ArianeGroup is developing the RIT technology and thinks it's a good way to serve telecommunication satellites. So this was mainly the part of ArianeGroup presentation.